Okay, boys and girls, welcome to lesson 6 of unit 1. And before we begin our lesson, we're going to do bell work. On page 17 is your bell work, and you're given 6 piecewise functions and asked to match them to the graph, to its graph. One thing I want to just caution you on the graph, the ticks mark goes up by 2. So be careful when you're reading the graph. Also, the best way of doing this is to look at Y-intercepts. That's going to probably be the easiest way to at least eliminate if it's a possibility. So go ahead and pause the graph, match these 6 piecewise functions to their graphs, and come back and I'll show you the answers. Okay, welcome back. I just kind of want to show you the answers. I've done it 2 different ways. I've numbered the graph itself, and I've also given you numbers at the bottom. Again, if you have any questions, make sure that you send me a message through Remind. Okay, so today we're going to start by writing a piecewise function. So our objective today is to write a piecewise function given a graph or information about the function. So this first video that we're going to watch is pretty much just writing the equation from a graph. And then in the second video, second part of today's lesson, you're going to be given information and asked to write real life information and asked to write a piecewise function. So the first thing we want to do with this piecewise function is we want to notice what is the domain of this function. I don't know what this looks like on your paper, but that is a closed circle. And so we want to ask ourselves, what is the domain? So we see that it goes on and on forever to the left. So we know that it goes from negative infinity. And then it goes on and on forever to the right, so it goes from negative infinity to infinity. Now, what is the range? What is the smallest y value this will be? Well, because this is going on and on and on forever downward, the smallest y value is negative infinity. What is the largest y value? Well, it goes up to this point, and there's an open circle on it, so it doesn't actually ever get to that point. So this is 1, 2, 3. So the highest it's going to be is 3. It never gets to 3, so we put a parenthesis around that. Is this continuous? No, it is not a continuous function because of this, what we call a jump discontinuity. So is it discontinuous? Is it continuous? No. And this type of discontinuity is called a jump because it jumped from one place to the other. Okay, so let's talk about writing our equation. We want to notice where is the graph broken into pieces. And we can kind of see that it's broken into pieces at this line. So what is that line? That is x is less than negative 2, and x is greater than or equal to negative 2. The reason I said greater than or equal to is because this circle is closed. Okay? And it's closed when it's greater than. Now, writing x is greater than negative 2, this should be easy because it's a horizontal line, and so it has a simple equation of negative 2. Y equals negative 2. Now, how do we write the equation for the second part of this line? Well, I'm going to advise you to do one or two things. One is to find the slope, and then if you can easily find the y-intercept, that's probably going to be the easiest way of doing this. So we can see, and I tell you that assume each tick mark is 1 unit, so we can see that this has a slope of 1. And what is that y-intercept? Well, if I were to continue this graph, I would go up 1 over 1, up 1 over 1, and this would be my y-intercept if that graph continues. So my y-intercept would be 1, 2, 3, 4, 5. And that's what we got. Okay? All right, let's do problem number 2. Let's start again with the domain. So once again, we see that this has an arrow and it's going on and on forever. So it goes from negative infinity. It has an arrow on this side, so it also goes to positive infinity. Now, my range is broken up. The function is not defined between these two values. So it goes from negative infinity to 1. And 1 is included because I think both of these are dark arrows. So it goes from negative infinity to 1. And then there's nothing between 1 and 2, so we're going to put a union sign. And then it goes to 2, and I'm going to put that in bracket because this one is closed. That's a closed circle. So it goes from 2 then to infinity. So is it continuous? Well, it's not continuous because we can see that there's a jump between those two. So is it continuous? No, it's not continuous. And the type of discontinuity, once again, would be a jump discontinuity. All right, this one has 3 parts to it. So we have to write 3 different parts, and we're going to have to look at the 3 different domains. So we see the first time it's broken at that point, and then again it's broken at this point. So what are those 2 points? This first graph, get a different color here. This first graph in orange is defined when x is less than negative 2, and we're going to say less than or equal to negative 2 because of the closed circle. And so what is this graph? So once again, let's find the slope. We see that it goes up 1 over 1, so it has a slope of 1x. And if I were to continue this, if I would go up 1 over 1 again, this would be my y-intercept, so it has a y-intercept of 2. Okay? I'm going to erase that, because I have to look at it again. All right. So the next part of this graph is defined between negative 2 and 2. So let me get a different color for this. Let's look at blue. So that we're going to look at this line. Both of the circles are open. And we see that it's between negative 2 and 2. And it's open circles on both of them. That's why it's not less than or equal to. So we want to find the equation of this line. Well, this one's a little easy. We can see that the slope is 1. And the y-intercept is 1, 2, 3. So that's the second part of that. Okay? Let's do the next one. Let me get a different color for that one. Let's do pink. And we're going to do this line. So that's that pink line. And again, we see that it is defined. It is defined when x is greater than or equal to 2, because there's a closed circle. So once again, our slope is 1. Our y-intercept, if we were to continue this line, we would go down 1 and over 1, and our y-intercept would be there. So it's plus 1. Okay? Excuse me. So it's easiest for these if you can find the y-intercept. Now, that's not always the case. Let's look at problem number 3. Again, for problem number 3, how many parts do we have? We have 3 parts in problem number 3. We have part A, we have part B, and we have part C. So we have 3 different parts. Part A is defined when x is less than or equal to negative 2. So that one's found when x is less than or equal to negative 2. The middle part, the yellow part, is defined between negative 2 and positive 2. So it's defined between negative 2 and positive 2. And because this function is continuous, technically I could also put less than or equal to on these as well, because it's going to be at the same point. So I could put less than or equal to. Generally, we only put less than or equal to on one of them, but because it's continuous, it doesn't matter. And the last part of this graph is defined when x is greater than or equal to 2. Okay, so let's write our equations. Now these, excuse me, these equations are going to be a little bit more difficult to write because we aren't going to be able to see where the y-intercept is. But we can find the slope. So remember, we take 2 points and we find the slope. Let me erase this just so it's easier to see what I'm doing here. All right, so we have this point and this point. So what is our slope? Our slope is 3. Now remember, we can take a point, any point on this line, and write the equation. So let's take this point, which is negative 1, 2, 3, and 1. So our equation of the line, using the point slope formula, would be y minus 1 is equal to 3 times x plus 3, because it's x minus a negative 3. We want to put this in slope intercept form, so we have y minus 1 is equal to 3x plus 9. So we get y is equal to 3x plus 10, adding the 1 to both sides. So the first part of that graph is going to be 3x plus 10. The middle line in the middle, the yellow line, is simply a horizontal line, so it's simply going to be 1, 2, 3, 4. So that's just going to be 4. Now we have to write the equation of the last part of this, the green part of that. And so once again, we have to find the slope and the y-intercept. And we see the slope here is, be careful, this slope is negative 3. And the point that we're going to use is 3, 1. Okay, so then this is y minus 1 is equal to negative 3x minus 3. So it's y minus 1 is equal to negative 3x. And a negative times a negative makes that positive. So we get y is equal to negative 3x plus 10. So then this one is 3x plus 10. And that's how we write that. What is our domain? Our domain is negative infinity to infinity because the arrows go on and on. Our range would go from negative infinity, but it doesn't go all the way to the top. It ends at the top, and so we're going to top that off at 4, and we're going to put a bracket because 4 is part of the solution. Now, this next graph is called a step function. And so let's see the 3 places where it's broken up. It starts at 0, and it goes to 2, and then it goes from 2 to 4, and it goes from 4 to 6. Okay? And they're all horizontal lines. So how do we write that? So this horizontal line is at 1, so my y is equal to 1, and that happens between 0 and 2. It's a closed circle on 0, so it's less than or equal to. Our next graph is at 1, 2, 3, and it's at 3 between 2 and 4. This is a closed circle, so that one will be less than or equal to. The last one is open, and then the last one is at 5, and it's between 4 and 6. And again, this is a closed circle, so it's less than or equal to. So what is our domain for this? Our domain for what we have drawn is simply, it starts at 0, and it ends at 6, but 6 is not included. and every x value in between there is included. Our range, however, well, we can either write it in interval notation or we can write it as a solution set. I'm going to write it in interval notation. Our range is 1, union, 3, union, 5. Because it is not continuous, and the numbers between 1 and 3 are not included. So we've already talked about this is not continuous, and again, it's jump discontinuity. Okay, what I would like for you to do is I would like for you to pause the video, and then I want you to do problems 6, 7, and 8. So pause the video, do problems 6, 7, and 8, and then we'll come back and talk about it. Okay, welcome back. For this problem, I'm just going to kind of do these quickly. My domain is negative infinity to infinity. The range is negative infinity to infinity. It is continuous, so it doesn't have any discontinuity. It's broken up at 0. So we have x is less than 0, and we have x is greater than 0. Both of them have a y-intercept of 0, so the first equation has a slope of 1, so this would be 1x plus 0. The second equation, the second part of this has a slope of 2, so that would be 2x plus 0. It's defined at 0, so it doesn't matter which one I do less than or equal to because it is continuous. All right, for problem 7, the domain is negative infinity to 2, and 2 is not included, and then it picks it up again at 3. 3 is included, and then it goes to infinity. My range goes from negative infinity, and then it goes up to 2, but 2 is not included. So that's a parenthesis, and then it jumps to 4. And it's just 4, so we just write the 4 because it doesn't go above that, but 2 and 3 are not included. Is it continuous? No. And the type of discontinuity, once again, this is jump. Okay, so what are my equations? I have 3 different equations. The first one is defined when x is less than negative 2, and then it's defined between negative 2 and 2, and then it's defined when x is greater than 3. That would be greater than or equal to. This first part, because of the open, it would just be less than, not less than or equal to. The second would be less than or equal to, but the 2 here is not included. All right, so my slope is 2. My y-intercept, if that were to continue, if I went up 2 and over 1, up 2 and over 1, I would end up here. So that's 1, 2, 3, 4, 5, 6. Between negative 2 and 2, it's just a horizontal line, so we got 1, 2, 3, 4. And this last one has a negative slope. It has a negative slope of 2. And if I were to continue that y-intercept, I'd go up 2 and over 1, up 2 over 1, up 2 over 1. So I'm going to say that that's plus 7. But again, if we wanted to do that using a point slope formula, we could take this point, which is 1, 2, 3, which is 3, 1, and then we'd have y minus 1 is equal to, we said the slope was negative 2, negative 2x minus 3. So y minus 1 is equal to negative 2x plus 6. So y is equal to negative 2x plus 7, which is what we got there. Okay? Alrighty, and finally, we have an absolute value function, which we're going to talk about in Unit 2, but my domain, I'm assuming, and if you didn't make that assumption, this is okay, that those are arrows. So we go from negative infinity to infinity, and our range then would go from negative 3 included to infinity. Is it continuous? Yes. and there's no type of discontinuity. All right, so let's write an equation for this. We can see here that our y-intercept is -1 and our slope is, we went down 2 and over 1. I'm sorry, we went down 1 and over 2, because this is 1. Okay, let me get my bearings right. So we went down 2 and over 1. Went down 2 and over 1. We rose 2 and ran 1. So my slope is -2x. My y-intercept is -1. And it's broken up at x equals 1. So this happens when x is less than or equal to 1. The second part of my graph, it also has a slope of 2, but this time the slope is +2. And my y-intercept, if I were to continue my y-intercept, I would go down 1 and over 2. So I want to say 5, but we're not sure, so let's just take this point. Let's see, what was this point? This point is 1, -3. And so my slope is 2. So I have y plus 3 is equal to 2 times x minus 1. So I have y plus 3 is equal to 2x minus 2. So I get y is equal to 2x plus 1. And that's not correct. My slope is 2. Oh, probably because that point is, yeah, -3. 1, -3. So 2x minus 1, y plus 3. We subtract 3 from both sides, and we get -5. Because I have to subtract 3 from both sides. Sorry, you probably saw that a minute ago. So I get 2x minus 5, and this happens when x is greater than or equal to 1. Okay, okie dokie, boys and girls. So much for writing the equation of a piecewise function. There's more practice of this in your homework if you'd like to practice it before going to the next video.